Okay, the logic, I mean, it looks is like that. I don't know that basically kind of makes sense that this one, when the load is here closer to the 40 center line between these two, that will be the maximum. However, uh, you know, what can happen is that you have to calculate the resultant force as we did before, and this is the resultant force, and the maximum moment is going to happen either in either one of the two loads that lay within the resultant force. So it could be here, which is what we did, but it could also be here. So if I put my resultant force in such a way between my center line, in such a way between my resultant force and this load of 25, that could be also a solution. So just for the sake of knowing what happened, let's change this and let's focus on to that part. So let's try to do that part, second 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 part. Low moment, assume maximum moment happens under 25 kilonewton load. If that is the case, then we have to once again center line, center line, center, center line, center, 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 center line. So we have to come here now, and what we have to do is this. We have to place our center line between the resultant force and that 25 kilonewton load. So that's what we are going to do. We're going to put here the 25 kilonewton load. Where are you? Where are you? Here. The 25 kilonewton load, the 20 kilonewton load, and the 40 kilonewton load here. 40 kilonewton load. There you go. Now I know all the other distances because the resultant force originally was here and it's still there, and I don't need to put it for anything. I'm just gonna put it to measure this distance, which is 2.47. Yeah, 2.47 that we calculated before. And now if I want to calculate the distance between these two, I know the total distance here was 4 and this was 1.5. This is given in the geometry of the truck. So if I put this center line in between these two, half and half, then I'm going to have 4 minus 2.47. That's going to be the total distance over there. 4 minus 2.47. 4 minus 2.47. That's going to be 1.53. Well, I'm going to put it here on the top. 1.53. And I'm not that interested in 1.53, but I'm interested in half of that because half has to be here and half has to be there. Half of that. 0.765. So these distances are 0.765 for this and for that, both of them. And then we have that. And then this is AY and this is BY. Now I know also that this is 6 and 6 here. And what? And I need to know the distance from here to here. And that distance from here to here, I can know it because I know this is 6 minus this plus that. Let's start with this. Let's start with the distance from this force to that point. This distance from here to here. How do I get that distance? That distance is going to be 6 minus 0.765 plus 4. 6 minus 0.765 plus 4. Or 6 plus 0.765 plus 2.47, which is the same thing. 6 minus 0.765 plus 4. And that is 9.235. 9.235. 9.235. I need that because we're going to calculate the reactions. Now the other distance that I need is the distance from here to here. That distance is needed also. And how much is that distance? That distance is 6, and on the center line, minus 0.765. 6 minus 0.765. So that distance is 6 minus 0.765, and that is 5.235. And last but not least, I need this distance. And how much is that distance? That distance is this minus 1.5. So it's going to be 5.235, and I'm here, right? Minus 1.5, I get that. I'm going to put it like that. 5.235 minus 1.5. Minus 1.5, and it's 3.735. There you go. Now we have every single distance that we need for this. Calculate the reactions. Reactions. In this case, let's do the same thing. Let's do summation of moments at B equals 0, and the only reason is because I did it like that last time. I could do summation of moments at A, calculate B, and then do the section for this side, but it's the same. So, summation of moments at B, then I have negative AY times 12 plus 40 times this distance, 9.235 plus 25 times this distance, 5.235 plus 20 times this distance here, 3.735. That has to be equal 0. Okay, let's see if I get that. 40 times 9.235 plus 25 times 5.235 plus 20 times 3.735 divided by 12, and that is 47.91 kilonewton. 47.91 kilonewton. Okay, now we have to make a cut under that load, because that's what the derivation, the previous derivation in the other video said, that the maximum moment should be underneath that load. And because I have this reaction, I'm going to use this section over here. So I have this reaction here, AY equals 47.91. I have this force of 40 kilonewtons here, and I have the force of 25 here, which it's not gonna do anything for the sake of the moment. So this is gonna be the moment, this is gonna be the shear, and I need the distances. This distance is 4 because it was given, it's from the geometry of the truck, and this other distance is gonna be 6 here to the center line. Center line 6. Actually, it could be calculated in so many different ways, but we already have this distance, right? So I can say that it's 12 minus 9.235, and that will give me that distance. 12 minus 9.235, that will give me the distance that I'm looking for. So 12 minus 9.235 is going to be 2.765. 2.765. How come 2.765? 2.765. Yes, 2.765. That's it. 2.765. 2.765. Remember, 12 minus that is that. So now we can calculate our summation of moments. Summation of moments at point C equal, then what do we have there? Equal 0. But then let's do this. Then we have AY negative 47.91. Remember, this is AY multiplied by this distance, 6.765, negative plus 40 times 4 plus m equals 0. M&M, chocolate, M&M, non-paid advertisement. M equals 47 times 47.91 enters minus 160 equals 164, oh my, 0.11. Look at that, surprise. La vida te da sorpresas. Life gives you surprises. Sorpresas te da la vida. Surprises are given to you by life. When we did it, we thought that the first location, which is, it was here, was gonna be it, because the heaviest load, 40, was closer to the center line in that case, to the resultant force, and we thought it was gonna be here, the maximum load. However, when we did this one, it was 160. When we did this one, it's 164.11, meaning the maximum absolute value is 164.11, and it happens under, when the truck is placed at that location, under the 25 kilonewton load. That's it. That's it for the moment. Now for the shear, I don't think it's worth it that I do it. I mean, I think that you can go and work it out on your own. For the shear, it's really easy. You just put the truck here. There's no calculation of any resultant force. You just put your truck over there and calculate for when the truck is just right there, not on top of the support, but just right there, really close to the support or really close to that support, and that should be the location for the maximum shear. And it's really easy to do, right? So you just calculate the reactions when it's like that, and the reaction when it's like that, and add the summation of forces in Y, and that's it. But this is a really interesting result, an interesting case also. So I see you next time. I hope that you like it, and if you don't, I'm so sorry. I'm doing my best. Bye guys, have a good day.